Tech by Tips.
Here I have logged into my Raspberry Pi 4B that is running the SD card that I'm going to use as an image to provision the LUNs in my NAS. So I have already made some configurations in there, for example the message of the day that comes up when I log in, also the host name, and I've installed Git and stuff like that, but I want to make sure that I cover everything. So here, another thing that we should do with this base image is we need to make sure that we have installed NFS common, and we also need to do an upgrade and an update to the system. So let's do the update and then the upgrade. This is running Raspbian OS, and when I boot the image for the first time I created my user, so that's why you see my name there as my user. So if you don't have a user that you want to use, then you need to create it using the sudo add user command, then follow that with the name of the user that you want to add. And also if you want to give like sudo permissions to that user, then you can also do that too. In this case I've already done all that I need for when it comes to the user, so I'm not worried about that. I'm just making sure that I have all the things that I need set up in this image before I make that into an image in my NAS. And we're done, so that's all that I wanted to first show in here, so we can clear the screen. And here we also don't need to do any EEPROM updates because we've already done that in a previous video, so we're good with that. The Raspberry Pi is already configured to try to boot from the network if it doesn't have an SD card plugged, so we're good on that side. Now we need to identify the serial number for this Pi. So if you're going to provision the Raspberry Pis using my Raspberry Pi Pixie server, there's an option there to figure that out. But if you're going to go directly into the Raspberry Pis and use that to set it up, you can find that out by running the following command. The cat proc CPU info should give you the information on the serial number of your Raspberry Pi. So it should be the last 2, 4, 6, 8 digits here in the serial number. That's the serial number that you need to keep a record of when you provision your Pi. By default, the Raspbian Bookworm image does not come with the iSCSI ADM application installed, so we have to install that. So we do open iSCSI, and that should install all the things that we need to use iSCSI in our Raspbian Bookworm Raspberry Pi. So we can validate that later when this is done installing, checking that we do have the iSCSI admin application available. Okay, this is done installing, so let's try to see. There we go. It seems like we do have it now available, so we can actually run commands using that, which is what I wanted to make sure. And now we can start connecting our Raspberry Pi to the NAS so that we can start copying the operating system files from the SD card into the LUN in the NAS. For that we use the command sudo iSCSI admin, so iSCSI ADM, and then on mode discovery, and then with type send targets, and then we put as the portal the IP of our NAS, and we run this command and we get that information there. And here we can check that we have not mounted yet anything to our dev SD whatever letter, so we should not get anything here, so we cannot find that, right? So now that we have retrieved the target here for our iSCSI, then we can copy this, and then in this command here we're going to replace the target for that target, and then it's going to be sudo iSCSI admin and mode node, and then with the target name, and then we put the target that we defined because we got it from over here, and then we're going to put the portal, which is going to be the IP of our NAS, and then we're going to put the command --login to that, and then it tells us that we're logging to that interface over there, and it says that the login was successful. So now if we run again this command here, we see that we still don't have access to that, and that is for a very simple reason. If we go back into our NAS and check our LUNs, remember that we said that our LUN was only going to be accessible by a host with the name Pi1, which means that the initiator for this connection has to be Pi1, and we have not updated that in the machine. So we have to do that. We have to edit two things here. So the first thing is we would have to do is etc hostname. We have to change that to match that host. So then Control X, Y, enter, and then we have to do that same thing with iSCSI initiator name iSCSI. In here we have to replace this full name that is at the end here with the name of our initiator that we specified, which in this case is the host Pi1, and then Control X, Y, and enter to exit out of this. And then ideally what I like to do here is for it to take on the changes that I made, I restart the Pi. So I do a reboot now and wait for the Pi to restart. Now that the Raspberry Pi has restarted, then we can try again to run those commands and see if they actually work this time. So first let's validate that we don't have any device here, and as we can see we don't see anything. So now we're going to go back into our list of commands and we are going to do the login here with the NAS IP address and the same information that we had before, and it said it was successful. And now we can do the I mistyped. So then now that we have rebooted and we have our initiator with the proper host name, and we can see that our host name has changed also here, then we can see that it was allowed to log in to the LUN and mount it. So we have it as the dev SDA device in our system. Now that we see the drive, we need to make sure that we update the iSCSI initramfs so that it uses that connection whenever it boots. So we'll run it with this command, with the sudo touch etc iSCSI initramfs, and then we're gonna do a sudo update initramfs, and that should update the initramfs to use that iSCSI target that we have connected to whenever we boot the system. And that has completed the buildup of that initramfs and saved it in the system. And now the next thing we're going to do is we need to format this using the makefs.ext4 to format it as an extension for partition, and then we select the name of that device, and then we'll see that it'll, in my case it says it was already an extension 4. It's because I ran the command and I forgot to record, so I have to redo it again. But in your case you wouldn't see that prompting you for proceed anyway. It'll just say discarding device blocks, and you just have to let it format the drive, and it's going to format it as an extension 4 drive. And then when that's done, we'll proceed with the steps. This is going to take a little bit of time, so just be patient. And it has formatted the drive, so now we can mount it using the sudo mount and then dev SDA. We're going to mount it into the mount folder, and now we should be able to see that as a mounted folder. And as we said, we gave it 64 gigs of space, so after all the little bit of space that it needs, we end up with about 63 gigs of usable space in that drive. So now we can clear out of here, and then now we're gonna run the command sudo block id, and we specify the dev SDA device so that we can get the identifier for that device. And we're gonna grab this value here and we're gonna copy that because we need to make a reference of that later. So let's just store it here in a notepad for now. So right now we have the serial, the iSCSI target that we identified, and now the UUID of the dev SDA, which would be the root of our file system. At this point we already have the LUN mounted into our Raspberry Pi into the mount folder, and it's formatted. It's an extension for file system, but it doesn't have anything. So now what we're going to do is we're going to use this command to transfer all of the files from our Linux operating system in our SD card into that LUN, which is a network drive basically, right? So we're gonna do the sudo rsync with the avhp flag, but we're gonna specifically tell it, do not copy the following folders. So we exclude boot firmware because that's the boot information that is gonna be somewhere else. We don't need it there. We're gonna also exclude the process folder. We're going to exclude the system folder, the dev folder, and the mount folder, because the mount is the drive that we're actually having in the network, so we don't need to copy that. That'll become an inception if we had that, trying to copy. So we make sure we remove that from there. So we're gonna be copying everything from the root into the mount directory, which is the network drive. We execute this, and it's gonna take some minutes to do that depending on your connection and the processor, etc. In my case, with the Raspberry Pi 4B with a 1 gigabit connection, it usually takes less than 5 minutes to transfer this. It's about 2.2 gigabytes with Raspberry Pi version Bookworm, so it shouldn't be a long time. Just be aware that if you have an older Raspberry Pi or your network is slower, then it's going to be something of a slower process. And just like that, I am done copying. It was copying about 2.12 gigs of data, and it took maybe 3 minutes or less. It was transferring at about 24 megabytes per second. So that's my case. Hopefully your case will be really fast too. And now we should see that. Let me clear this out, and let's do an ls on the mount directory, and then there we go. We have our Linux file structure, except for those folders that we said that we didn't want to copy, but those folders are part of the Linux file system. So what we're going to do is we're going to create those, but we're going to create them blank. So we're going to use the sudo make directory on the mount folder, and then we're going to tell it inside there, create the dev, proxies, boot firmware, and mount folders, so that they exist there because they're necessary for Linux to boot properly. So we execute this command, and then when we see what we have in there, we have more folders because those folders have been created. As you can see, we have the sys, which was not here before. We have the dev, which was not here before. We have the mount, which was not here before. So now we have all the things that we should have in our Linux file structure in that LUN, which is our network drive. Great, so now our file structure is in our network drive, but we have to make some changes to those files to make sure that when the Pi is booting, it boots properly. So let's first clear this there. Let's go into we're gonna open a file with nano, and that file is in the mount directory, so that's the LUN, the network drive, and we need to edit the etc fstab file. That's the file that mounts the boot partition and the actual Linux file system to the system. So we need to make changes there. So we open here that information that we stored. So we need this UUID that we copied that represents our root file system, because we need to change that here. So we see that we have the boot firmware here, and we have the root file system. So we're going to make a change first here in the one for the root file system. We're going to replace this UUID of the partition with that UUID of the drive, and we need to make sure that this changes to, instead of partition UUID, to just UUID. So now we are saying use this UUID. It's not a partition UUID, it's a network drive, and then it's going to be mounted to a root directory, so the slash, and then we're going to leave this as an extension for file system because that's what it is. And then we're just going to get rid of the no A time here, and we're going to put this as a 1, and that looks good. So now on the upper part here, we're going to do something else. Remember that we're going to be using an NFS to serve the Raspberry Pi the boot firmware that it needs to boot. So we're not going to use a part UUID here at all. What we're going to do is we're going to mount an NFS share. So we're going to put the IP of the NAS, colon, and then the share that we're going to be using. In my case, it's going to be volume1/pixie, and then inside there we have a folder named boot, and after that we have the serial number of this Pi that I have already saved here, so we put that in there. And by doing this, now we are saying that our boot firmware, it should be something that it grabs from that NFS share. So here it's not going to be vfat anymore, this is going to be an NFS share, so we change that. And then here on default we're going to put an extra thing that says _netdev, and then here we're going to replace that to 00. So that's all the changes that we're going to do for this specific Pi. We're specifying where the boot partition for this Pi is in the NFS share, and we're also specifying the UUID of that network drive that we have configured here for it. So now we can control X, Y, and enter to save, and then we can validate that by just writing that out to the terminal, and it looks good. It has what we needed here. Okay, now that we have transferred all the contents of our file system, we don't need to have that mounted anymore. So we're going to go and do sudo umount, which is the onmount command for that MNT partition that we had. So before, let's just validate. You see MNT, so sudo umount MNT, and that should unmount that so it's no longer mounted. And then additionally, we want to disconnect from the LUN, and for that we're going to run this command, which is the same as before, but we're going to end with logout at the end. So that's going to disconnect from the LUN, and as you can see, logout was successful, so now that should not be mounted. So we're done with transferring all the file system into the LUN in our NAS. The next thing that we need to do is then copy the contents of our boot firmware into our NAS that is going to be used by the Raspberry Pi Pixie server. Tell the Pi where to boot from. So in here, let me show you for a second here. In my directory here for my Raspberry Pi Pixie server on the NAS, I have the boot folder, and in there I have the old boot for this Raspberry Pi that was using NFS, and I created a new folder to dump the files that we're going to be dumping right now, and as you can see, it's empty right now. So we're going to point to this folder to copy all the contents of the boot firmware directory. Why boot firmware? With Bookworm, the way that the boot structure is in the SD card changed, so now it's no longer the /boot directory that is used to boot, but /boot/firmware. So we're gonna copy that into that NAS share. So let's clear this up. Okay, now, so I am going to mount the folder that I have in my NAS that is for the boot files into the system under the /mount folder. Running this command, sudo mount, using the NFS system, using the TCP protocol, and then I'm going to put the IP of the NAS and then the path of that NFS share. And when we run this, we should now see that we have a new mount that is on the mount directory, and it's mounted to that folder that we have created. So if we do a list of that directory, right now we don't have anything, which makes sense because I don't have anything in there. We can create a new file here just to test. So we have a new text document that's list again, and now we have that new text document. So we know that we are mounted to the right place. Now let me get rid of that because I don't need that file in there. So that's out. And now that we have that mount location, then I can go ahead and start copying the contents of the boot firmware, which is where now our boot files are located, into that location in our NAS. So we can go ahead and do that now with the following command, /*, so we grab all the files inside that folder instead of the folder and we move it. Let's run that again and see if now it works properly. And there we go. now in the boot with that serial, and we have all those files that were in the boot firmware located there. And as we can see, everything was fast, it was done pretty quickly. So now we're done with moving those files into the NAS for the boot partition. And now that we have all the files that we need in here, there's a few changes that we need to make here to make sure that our Raspberry Pi works for our purpose. In my case, I'm going to be using these Raspberry Pis to run a light Kubernetes cluster. So the first thing I need to do is I need to go into the command line file, and I need to make changes in here to make sure that it satisfies all the things that I need for this. So I'm going to make some changes here, and I'm going to explain them in a bit. Okay, first of all, we start here by leaving console serial 0 with 115/200 bandwidth as it is. We leave the console TTY as it is, and here's a first important change that we have to make. This is pointing to a partition UUID as the root of our file system, but as we said before, we're not going to do that, so we're going to remove the partition part. We're just going to leave it as a UUID. And in here, we're going to replace this partition number with the number of that LUN that we got before. So we put that in there. And then we leave the root file system type as extension 4. That's fine. And then the file system check repair, yes, that's good. And here, let's put something before the root wait. Let's say elevator is deadline. And then we leave the root wait. Then let's also put fix RTC, and then we're gonna use the very important thing that we need to be able to boot from the iSCSI LUN, which is we need first to put an iSCSI initiator first. So the initiator is the name of our host, which is Pi1 in this case. So iSCSI underscore initiator equals Pi1 in my case. Then I'm gonna go ahead and put the iSCSI target name, and that's gonna be equal to that target that we identified before. So it's gonna be this one here for me, which I retrieved using the command in the Raspberry Pi. So that tells me where it needs to connect, what's the target for the connection. And then after that, I'm going to put an iSCSI target IP, and that's going to be the IP of the NAS. So in my case, I'm going to put that there, iSCSI target IP, and then I'm going to put the iSCSI port, which is going to be 3260, and then we're going to make that read write. So for the iSCSI, we have the initiator, which is the host that we're going to give permission to this specific LUN, the iSCSI target, which we retrieve from the console, the iSCSI target IP, which is the IP of the NAS, and the port for the iSCSI, which is 3260, and we make sure that that's read and write. And in my case, since this series of Pis are going to be used to run a light Kubernetes cluster, I also need to put this following entries, which is cgroup enable CPU set, cgroup memory 1, and cgroup enable memory, so that I have all the things necessary for it to be able to run properly in the Kubernetes cluster. So I would say the main important thing here is remember the root has to be a UUID, and it has to be the ID of that LUN. And you also need to put the iSCSI parameters so that it is able to connect to that through the network. And then if you're going to use it for light Kubernetes, then these three here. We save this, and that's the change that we have to make to that file that is in the boot folder of our NAS, the command line text. And now we should be able to just shut down the Raspberry Pi right now to disconnect the micro SD card. Since I already have the Raspberry Pi Pixie server listening, we should be able to now boot that Raspberry Pi from the network, and it should be able to boot from that LUN. This Raspberry Pi here has been shut down from the command, but it's still on, so let's power that off by clicking a button that I have here. And now I'm going to go ahead and remove the micro SD card from the Raspberry Pi because it doesn't need it. it's gonna boot from the network now. So let's now start it by giving it power, and we're gonna monitor how it behaves once it starts booting. So here you can see it's booting up, the SD card is outside, and we see the blinking lights, and I can see an image now on my monitor, so it's starting to boot from the network, and I'll show you that in a bit. So now if we track here the image, we can see that it is actually booting. It found something in the network. Takes a little bit of time, but eventually we'll see here it starts booting, and it will come to a part here where it's going to say that it's connected to the LUN. Here we go, iSCSI initiator. It was fast, but it's there, and as you can see now, it is booting normally. No problems at all. And our Raspberry Pi is ready to be used. So we are good. To further validate that everything is working properly, I'm going to log into the Pi. As you can see here, I am logged in. Let's clear this out. And here on the top, we're going to see what do we have as our drives. And as you can see here, it tells us that we have from the NFS share the boot firmware. So we have our boot partition from the network. And if you also see, the root of our system is 64 gigs, and that's the dev SDA device that is residing in the network. Because like I said, and as you saw, I pulled out the SD card. So this is coming directly from the LUN in the network. Additionally, if we come to the NAS, we'll see that our iSCSI target is saying that it has one connection. So if we check, we have mapped this to all the different devices, but we're specifically connected to the Pi 1, which is the LUN for Pi 1. So this is the one that is currently being used, and as you can see, it says the status is connected. So everything is working properly, and we are ready to start using our Raspberry Pis, booting from the network as if it had a disk per se instead of using network file sharing, which is NFS, because this is more of a lower level kind of file management and gives us better performance and better compatibility to do a lot of things with the Raspberry Pis, and it allows you to safely back up and restore. In the case that you create the LUNs with thin provisioning, you can do that. In my case, I went with thick provisioning, so those features are not really available, but if you go thin, you can do that. So yeah, we got a Raspberry Pi booting and our LUN is ready, so everything looks good. Remember, if you like the content, like and subscribe to the channel. I'll really appreciate it. It helps us grow. And remember, you can always leave comments on things that we'd like to see featured in the channel. So I'm going to leave it here. Remember, you can always donate with the link in the description below through PayPal or with Bitcoin, and I would really appreciate it because that helps me stay focused on creating content for the channel. So if we eventually can get to the point where I can actually just entirely focus on the channel, it'll be even better for you as a consumer of the content. So thank you very much. I'll see you on the next one.